Solidification variables. The solidification process by which a liquid metal freezes in a mold plays a crucial role because different solidification conditions give rise to different microstructures and hence the properties of the as-cast alloy. The variables affecting the solidification behavior of a casting include the type or composition of casting alloy. An alloy consists of a base metal to which other elements are added to obtain favorable properties. When an element is added to the base metal, it significantly alters the solidification process. This is because an alloy freezes over a range of temperatures. Thus, proper control of alloying elements promotes constitutional supercooling, and further, the additional use of inculcating agents promotes heterogeneous nucleation, resulting in fine-grained structures in the cast metal. Thermal properties of both the alloy and molding material and cooling rate. The heat released during solidification is very large, and as such, it must be extracted quickly. The higher the melting point and thermal conductivity of materials used in casting process, the larger is the latent heat energy released or absorbed of fusion. Further, the heat extracted per unit time, which is defined as the cooling rate, depends mainly on the mold material and the air gap formed at the metal mold interface. High cooling rate promotes directional solidification at a faster rate with finer grains, while low cooling rate exhibits larger grains. It is important to note that the grain size affects the strength and hardness of the casting. Also, metallic molds produce higher cooling rate than a sand mold under the same operating conditions. Mold thickness and shape. The thickness of mold influences solidification time or heat removal rate. In case of sand molds, heat removal rates are increased by a decrease in mold thickness below a certain critical thickness. However, for the same thickness, solidification is faster in metallic molds. Chills, gating, and other casting design factors. Solidification takes place at a certain rate relative to the thickness of the casting. A casting should be designed to achieve controlled progressive directional solidification so that it becomes free from solidification related defects. Location of gates and risers, use of chills, and other means for controlling the freezing process must be adopted suitably for complete solidification to take place. Pouring temperature. The pouring temperature of the molten metal must be higher than the solidification temperature of the metal. This will help the molten metal to flow into all regions of the mold before solidifying and overcomes the solidification related defects. However, the temperature of the melt must not be very high, as this might saturate the gases, resulting in the formation of oxides. Also, the molten metal at high temperature has the ability to penetrate into the surface of the mold material.